Welcome to today's episode of our mathematics class. In this lesson, we are going to look at approximation to the nearest significant figures. By the end of this lesson, you should be able to define a significant figure, state the significance of zeros placed at different positions in a number, state the significance of non-zero figures. A significant figure is a digit that contributes to the accuracy of a number. These figures provide meaningful information about the number, especially in the context of scientific measurements. That is to say, when a figure do not contribute to the accuracy of a number, it is not significant. And also, when a figure do not provide meaningful information about a number, it is not also significant. Now, you have to take these 2 points to heart. Number one is when a figure do not contribute to the accuracy of a number, it is not significant. Then number two, when a figure do not provide meaningful information about a number, it is also not significant. Having this in mind, let's proceed to knowing the significance of zeros placed at different positions in a number. The 2 zeros placed before the digits 1 and 5 do not meet any of the requirements of a significant figure. They do not contribute to the accuracy of the number, neither do they provide any meaningful information about the number. Whether the zeros are there or not, the number is 15. So the zero do not provide any accuracy, and it did not even tell us any meaningful information about the number. Zeros that appear before a non-zero digit are called leading zeros. Therefore, we can say that leading zeros are always not significant. In number 2, when the same zeros were placed in between 1 and 5, they became significant because they now give meaningful information about the number. In number 1, we have 15, even in the presence of the zero. But in number 2, when the zeros were placed between 1 and 5, the number became 1005. Therefore, we can say that when a zero or group of zeros are placed in between non-zero numbers, they are significant. Zeros placed in between non-zero numbers are called captive zeros. In essence, 1 and 5 are holding the zeros captive. Therefore, we can say that captive zeros are always significant. In number 3, these 2 zeros were placed behind 5. Yes, they might have influenced the number by making it 1005 instead of 15, but they do not give any meaningful information about the number, neither do they contribute to the accuracy of the number. Why is that? This answers the question of adding .00 to receipts, deposits and withdrawal slips. A number that ends with 0 is often followed by .00 as in number 4. The difference between 3 and 4 is that 3 has no decimal point, but 4 has a decimal point. Zero that comes behind a non-zero digit are called trailing zeros. Therefore, we can say that trailing zeros are significant if and only if there is a decimal point. Hence, number 3 has only 2 significant figures, 1 and 5, because there is no decimal point contained in it. On the other hand, the zeros in 4 are significant because there is a decimal point. We would understand this better when we try to solve practical examples. Unlike zeros which depend on their position in a particular number, non-zero numbers are always significant. That is to say, they do not depend upon their position in a number. Anywhere they are significant. So take note and always remember that non-zero digits are always significant. So we can summarize by saying all non-zero digits are significant. Leading zeros are not significant. Captive zeros are significant. And lastly, trailing zeros are significant only when there is a decimal point. Just like approximation to the nearest decimal place, when approximating to the nearest significant figure, focus on the digits immediately after the required significant figure. That is your reference number. In example 1, you are given 00123 to approximate to one significant figure. If you look at this number very well, you would observe that we have leading zeros and non-zero numbers. Remember what you said, that non-zero numbers are always significant. Therefore, we have only three significant figures here because the remaining two zeros, which are the leading zeros, are not significant. So we have three significant figures here. And if you are asked to approximate this number, that is number one, to one significant figure, your reference number becomes the second significant figure. Same way, when you are asked to approximate the number to two significant figure, your reference number becomes the third significant figure. When asked to approximate to three significant figure, your reference number becomes the fourth significant figure. And when asked to approximate to five significant figures, your reference number becomes the sixth significant figure. That is to say, for approximation to the nearest significant figure, the reference number is always the significant figure next to the required significant figure. Now, if you are asked to approximate a number to one significant figure, know that the reference number is the second significant figure. When asked to approximate to two significant figure, know that the reference number is the third significant figure. And when asked to approximate to three significant figure, know that the reference number is the fourth significant figure. Before we start solving these questions, let's quickly revisit how to count significant figures. Remember that every non-zero digit in a number is always significant. Non-zero digits include digits from 1 to 9. All digits apart from 0 are non-zero digits. And you should also recall that leading zeros are not significant, captive zeros are always significant, and trailing zeros are significant only when there is a decimal point. Also, for approximation to the nearest significant figure, the reference digit is the digit next to the required significant figure. Let's get started with question 1. Please, there is a point here, 3.05994. The number of significant figures in question 1 is 1, 2, 3, 4, 5, 6. We added 0 because 0 is a captive zero. And because 0 is a captive zero, it is significant. And remember, all non-zero digits are also significant. So we have non-zero digits 3, 5, 9, 9, 4. They are significant plus this captive zero. Altogether, we have 1, 2, 3, 4, 5, 6. So we have 6 significant figure here. To approximate to one significant figure, the second digit becomes our reference number. Here, the second digit is 0. 0 is a random number, therefore the preceding digit remains the same. So this is 3 to 1 significant figure. Then to approximate to two significant figure, the third digit becomes your reference digit. So the third digit is 5. 5 is a round-up digit, therefore the preceding digit is increased by 1. We have 3.1 to two significant figures. To approximate to three significant figure, the fourth digit becomes the reference digit. Therefore, the fourth digit is 9. 9 is a round-up digit. Therefore, the preceding digit is increased by 1, and our answer becomes 3.06 to three significant figures. Then to four significant figure, the fifth digit becomes our reference digit. The fifth digit is still 9, and 9 is a round-up digit. Therefore, the preceding digit is increased by 1. But the preceding digit is 9 too. If we increase it by 1, we'll be having 10. Note that there is no number after the decimal point that is even 10 or greater than 10. Therefore, what we will do is to roll over the 1 to 5, making it 6, and we write down the 0. So we have 3.060 to four significant figures. To count the number of significant figures here, you should have in mind that all non-zero digits are significant. Therefore, 1, 3, 5, 6, 2 are significant, and the zeros here are captive. Captive zeros are also significant. Therefore, the total number of significant figures here include 1, 2, 3, 4, 5, 6, 7, and we have 7 significant figures here. Now, to approximate this to one significant figure, the second digit becomes our reference digit. Therefore, this is our reference digit, 0. 0 is a round down digit, therefore the preceding digit remains the same. So we write 1, and from here becomes 0, 0, 0, 0, 0, 0, 0. This is to one significant figure. Now, anytime there is no decimal point and you finish rounding off, you turn the remaining numbers to 0 as far as there is no decimal point. To two significant figure, the third digit becomes our reference digit. This third digit is a round down digit, therefore the preceding digit remains the same. So we have 1, 0, and all here zeros. 0, 0, 0, 0, 0. We have this is to two significant figure. Then to approximate to three significant figures, the fourth digit becomes our reference digit. 5 is our fourth digit. 5 is a round up digit, therefore the preceding digit, which is 3, is increased by 1, and we have 104. Then here becomes 0, 0, 0, 0, 0. This is to three significant figures. Then to four significant figures, the fifth digit becomes our reference number. The fifth digit here is 0, and 0 is a round down digit, therefore the preceding digit remains the same. We have 1035, then from here will be 000. This is to four significant figure. To solve this to one significant figure, the second digit becomes our reference digit. The second digit is a round down digit, therefore the preceding digit remains the same. So we have 7, and all these become 0. 0, 0, 0, 0, 0. And this will give you one significant figure. Then to two significant figure, the third digit becomes the reference digit. The reference digit is a random digit, therefore the preceding digit remains the same. So we have 7, 0, and all this becomes 0. 0, 0, 0, 0. This is to two significant figures. Then to three significant figures, the fourth digit becomes our reference digit. The fourth digit is 9. 9 is a round up digit, therefore the preceding digit is increased by 1. So we have 701, and all here becomes 000. This is to three significant figures. Then to four significant figures, the fifth digit becomes our reference digit. The fifth digit is 3. 3 is a random digit, therefore the preceding digit remains the same. So we have 7009. These two become 00, and this is four significant figures. In question 4, to get the number of significant digits here, we should remember that leading zeros are not significant. So these zeros here are not significant. We only have 1, 2, 3, 4, 5 significant digits. 5 significant figures here. To approximate 0.0089845 to one significant figure, the second digit becomes our reference digit. The reference digit is 9. We are ignoring these zeros because they are not significant. Therefore, the second digit is 9. 9 is a round-up digit. Therefore, the preceding digit is increased by 1, and we have 0.009 to one significant figure. Then to approximate this to two significant figures, the third digit becomes our reference digit. This third digit is 8. 8 is a round-up digit, therefore the preceding digit is increased by 1. But remember what we said earlier, we cannot put 10 here because there is no number after the decimal point that is equal or greater than 10. What we will do is, instead of writing 10, We will take this one and add it here, then drop the 0, and this will become 0.00. 1 plus 8 will give you 9, then you drop the 0, 0. So this will give you two significant figure. Then to three significant figure, the fourth digit becomes our reference digit. The first digit is 4. Then we have 0.0089. Because 4 is a random digit, the preceding digit remains the same. So 8 to three significant figures. Then to four significant figures, the fifth digit becomes our reference digit. The fifth digit is 5. 5 is a round-up digit, therefore the preceding digit is increased by 1, and we have 0.008985 to four significant digits. In this example, we are required to write down the number of significant figures in the following. Number 1, we have 120,000. Remember, we said that trailing zeros are not significant. Therefore, all these zeros are not significant. We only have two significant figures here, 1 and 2. So these two significant figures. Then number 2, our rule tells us that trailing zeros are significant only if there is a decimal point. In number 2, there is a decimal point. Therefore, all these digits are significant because of the decimal point. So the significant figures here include 1, 2, 3, 4, 5, 6, 7. We have 7 significant figures here. Then number 3, 120,000 point. To solve this, we should know that the non-zero digits are significant, that's constant. And again, the zeros in between 2 and 3 are also significant because they are captive zeros. Therefore, all the whole digits here are significant. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 significant figures here.